Hi class, welcome to Lesson 8 of Unit 1. In this lesson, we're going to focus on recognizing that chemical formulas can be used to identify substances. Substances, also known as pure substances, include elements and compounds. We are also going to be able to look and create formulas that represent the number of atoms in each element of a chemical formula. From this diagram, you can see that there are three major parts of all chemical formulas. The chemical symbols pictured here in red indicate the elements that are present. The subscripts pictured here in green are lower numbers that follow a chemical symbol. They tell us the number of atoms of that element. The subscripts of 1 is never written. So here we have 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. Lastly, we have coefficients, which can tell us how many of those entire chemical formulas we have. So here we have 3 sulfuric acids. Here are the steps that I recommend you take to count the atoms in a chemical formula. First, write the chemical formula. Then, list the atoms. Count the number of atoms of each element in one compound. Multiply the number of atoms by the coefficient. And finally, make sure that your answer makes sense. Think about it. Sometimes it is helpful to draw out a compound, though generally in chemistry we'll get so good at this that you'll be able to examine the numbers easily. So remember that subscripts apply only to the atom that it's behind. So in this symbol, the 2 behind the H means I have 2 hydrogens. Notice here in the image we have 1 water. Water consists of 2 hydrogen and 1 oxygen atoms. But when we take into account the coefficient, here we're going to have 2 water molecules. So notice the 2 water molecules, which have a total of 4 hydrogen and 2 oxygen. Sometimes parentheses can be found in formulas. If a subscript is outside of parentheses, it applies to all the species inside the parentheses. Here, barium hydroxide has 1 barium, 2 oxygens, and 2 hydrogen atoms. Let's look at this example here. Here we have 3 as a coefficient, and H subscript 2 and O with no subscript at all. This is commonly known as 3 waters. The coefficient 3 here means I have 3 entire water molecules. If we draw an image of 3 water molecules, notice that each water molecule has 2 hydrogen and 1 oxygen. Altogether, we now have 6 hydrogen and 3 oxygen. Take a minute to examine this example, aluminum sulfate. Here we have subscripts and parentheses. Since the subscript 2 follows the aluminum symbol, that means I have 2 aluminum atoms. Sulfur is in parentheses with a 3 outside. That means I have 3 sulfur atoms. And oxygen in parentheses has a subscript of 4. And outside the parentheses has a subscript of 3. So we multiply the 3 by the 4, meaning there are 12 oxygen atoms. That concludes this lesson. See you in